We lost all that good stuff about the questions, but what are you gonna do? Bless you. All right, if you're already finished, I went ahead and wrote up, first of all, what goes outside the box. If you started with like -7 or something else, you're not going to get to the right answer. And then after that, I would just focus on that bottom row. Yes. Yeah. All right, so before we go over anything else, we had a question about where does the 0 come from? So yeah, that didn't happen in our first example. Basically, you can't skip a degree when you're writing out your coefficients. Notice in the polynomial x cubed minus 57x, it skips that second degree term. Okay, so we put a 0 as kind of like a placeholder. All right, so good question there. Then we're checking the bottom row, as you guys had some time to work there. 1, 7, -8, 0. If that doesn't match up, then you kind of look at the other details. So anybody need me to kind of talk you through this? Or are we feeling okay now that we've seen it, tried it, seen it? Is that enough? Or do you need some verbal stuff there? Everybody good? All right, so our answer would be x squared plus 7x minus 8. Now, again, think about what that really means. That means that, if I took x squared plus 7x minus 8 times x minus 7, I would get x cubed minus 57x plus 56, right? So it tells me some good stuff. Any questions before we move on? We'll practice it more in the next examples. All right, so example 3 and example 4 kind of show us some real ways that we can use synthetic division. I've already talked about a couple of them, but we'll go ahead and practice those in these examples. So example 3 wants us to check if each is a factor. So that was kind of the second part of our learning target. So the question in A is x minus 3 a factor of the given function p of x? Why or why not? All right, so the way we're going to do that, because once you get good at it, it's quick, easy, is to use synthetic division, okay? So go ahead and try to set it up, and if you want to work ahead more than that, you can, but I'm going to write up how it should look in about 10 seconds. So what goes outside the box? What goes inside the box? I'll write that up in just a sec. Give you a chance to make mistakes here. Sometimes that can be the best teacher, All right, so what I was looking for was 3 goes outside the box. Inside the box, we would have 1, -7, 11, and 3. Again, I don't need any zeros there. If it's a cubic that I'm dividing into, I should have 4 numbers, right? Always one more than the degree. So I have 4 numbers, okay? Any questions about setting that part up? All right, now we'll go through it. So I'm going to call on you guys for some help here, okay? All right, so what do I bring down first? What happens first? Bring down the 1. Very good. All right, now what goes under the -7? 3. Very good. What goes under those 2? -4. What goes under the 11? -12. Very good. And what goes under those? -1. And what goes in our last little spot? -3, and then 0, right? So any questions about any of those spots? A lot of people were saying it, but not everybody gets it. So anybody have any questions about where any of those numbers came from? Yeah. The -3, it's just 3 times -1, right? So, where'd this 3 come from? 3 times 1. Where'd this -12 come from? 3 times -4. Where'd this -3 come from? 3 times -1. Does that make sense? So you add and then you multiply, right? Add, multiply, add, multiply, add, multiply, as long as it takes. All right. Anything else procedurally? If you haven't already done so, go ahead and write out the quadratic function that 1, -4, -1 represents. So that should just be x squared minus 4x minus 1. We still haven't really answered the question. Is it a factor? So what would you guess based on what's written on the board? Yes, no? Yeah, why do we say yes? Yeah? Has a remainder of 0, right? Just like 2 is a factor of 6. If we divide by 2, we get a remainder of 0. That's all we're looking at, okay? So the answer would be yes, because the remainder is 0. Okay, so all we really cared about there was that remainder. Okay. All right. Now with a little bit less help, you guys try the next one. Is it a factor? Why or why not? So we're taking x plus 5 into 4x cubed plus 21x squared minus 1x minus 24. Don't assume it's wrong if you get a non-zero remainder here. That hasn't happened yet. That does not always have to happen. I was reading about our first game, Sam. I heard this kid named Sam Higgins dropped 9 on him. Love that. I was cracking up too. They were talking about Caden Stewart. Like, he just comes from his handbells concert and he's just throwing down alley-oops. I was like, that's probably the funniest thing I've ever read in a sports article like that. All right, so go ahead and work through this from here. All right, so I went ahead and did that kind of without talking. If you do it right, you end up with a 6 remainder, okay? And that's kind of what we care about here. We would have no, because the remainder is some other number that's not 0. And again, well, actually, let's just take a second here before we move on. So like, how would I write out one of these with the remainder? Because you will have 1 or 2 of those on your homework, and we haven't done this yet. But how you would write out this expression would be 4x squared plus x minus 6. That part should be easy. And then the remainder, if it's not 0, here's how we write it out. So we do plus 6 over whatever we divided by. So over x plus 5. That's how you write a remainder. So it's always this weird looking fraction at the end if it's not a factor. Okay. Questions before we move on? All right. So our last example will be one more way we can just kind of use the remainder. So let's go ahead and kind of look at this. So use synthetic division and the remainder theorem to find the following. What's p of -4? So remember what that means first. So this means x equals -4, or if it were written as a factor, that would be x plus 4. Okay, just some things to remember. But anyways, what we divide by in this case would be, if we're using synthetic division, -4. Going into, I'm going to give you a chance to write up what goes next. Give you a chance to make a common mistake here. I'll write it up in about 10 seconds. Actually, I'm feeling impatient. Let me go ahead and write it up. All right, so where do people mess up there? Didn't add the 0, right? Remember, if it's 5th degree, you should have 6 terms. If we don't have that 0, we only have 5 terms. We skip something. Okay, easy to forget. Now this is a good one to test your speed on, right? Go through and try to do the process. I'll do it without talking, and we can compare at the end. All right, so the bottom row should be 1, -7, 0, 0, 5, 0. Anybody have any questions on that part? All right, so if this is called the remainder, that's all we really care about, okay? So what this tells me then is that the official answer to the question is P of -4 is equal to 0. -4 is one of my zeros. That's one of my x-intercepts if I looked at the graph, right? All right, now, before you pack up on me, try that last one. There's a couple zeros to set up your division. We'll go over it, and that'll be how we finish. That'll be our lesson on synthetic division. And you do get a relatively large number at the end, so that doesn't make it wrong. Your answer is going to be somewhere between 100 and 200. Almost right in the middle. All right, so I just showed it. The last row, the bottom row should be 2, 6, 17, 51, 151. So 151 is our answer. And again, sometimes we can miss the forest for the trees, right? So what we actually found out there was, don't worry about trying to do this on your calculator, but if I type that function out in my calculator, 2x to the 4th minus 1x squared minus 2, and then I go to a table, watch what I find when I go to where x equals 3. Right? Where x equals 3, y equals 151. So that's kind of what that remainder tells us, the value of the function at that x point. Okay? But anyways, there you go. Hopefully this helps. You got a homework over this that's posted now. So